Welcome to the project demonstration of automatic railway gate controlling system based on the train detection by using two IR sensors. So here we are using two IR sensors in order to identify the train in bi-direction. If it is coming in this side, then the gate will be closes, and if it is come this side also, the gate will be closes. And whenever this IR sensor act as train arrival detection, and the same time this IR sensor will act as a train departure detection. So if it is detects a train arrival, and then it will act as a train departure detection sensor. And whenever the train is arriving, the gate will be closes, and the buzzer also will be on, just in order to intimate to the citizens the train is arriving status. And here we are providing the two power supplies, one power supply for the motherboard and another power supply for this DC motor. So coming to this board, there we are using L293D motor driver. So as you know that L293D is a motor driver IC which can control the two DC motors and in the bidirectional manner. So now we are need only control one DC motor as for demonstration purpose, and we are using only one H bridge circuit, which is it has a two H bridge circuits, one H bridge for the one DC motor. And here the connections are, we have interfaced two IR sensor at A0 and B0 pins, and L293D motor driver at C0 and C1, and buzzer at C3 pin of our microcontroller. And coming to this motherboard, it needs 5 volts power supply. We are providing 5 volts power supply exactly from this adapter, and which will provide the 5 volts power supply directly into this. And this is the reset switch to restart the microcontroller, and this one is the crystal oscillator, steel plated one, which will provide the 20 megahertz clock frequency to the microcontroller. And there we can see two LEDs. Red light is the power status, and a green LED is programmable indication. Just the controller started execution, it will be indicated to this LED. It will on and off 2 times initially. So coming to this buzzer board, there will be one transistor, as the microcontroller can't drive the maximum current which can handle by this buzzer. So that's why we are using a transistor. As we know, the transistor will act as a switch. So here we are using transistor to trigger the buzzer. So initially provide the power supply to this motherboard, and once we provide the power supply, then there we can see the light is buzzer and on off 2 times. So here we need to remember one point: whenever the obstacle is there, then only the light on. Okay, we need to check that. Then only you need to provide the power supply to the main L293 motor driver. Now just restart the microcontroller and then provide the power supply to the motor driver also. Right now, now you can restart it. So initially the gate will opens, and the passengers, the customers, citizens can move throughout the gate. And when this train is arriving, then the gate closes. After train passes away, then the gate opens again. If the train is coming from this side again, right, as we discussed, so if it is arrival sensor, then it will turn into the departure sensor. And if it is arrival sensor, and then it will be a departure sensor. So like this we are going to detect the train arrival and departure using the IR sensors. In real time we are going to place these particular sensors at the directly high lines, means there we can detect only trains instead of detecting the animals. Right, thank you.